In this lesson, I'm going to review some information about logarithms, especially natural logarithms, and about exponential functions. This is partially reviewed in your textbook in section 5.1, the first thing we're going to do. Okay, so first recall, remember that when you have the log base b of x equals y, this is a function that you work with in pre-calculus, that means the same thing as x equals b to the y, being able to switch back and forth between log form and exponential form for general logs and general exponential functions. We will primarily be working with the natural log, which is log base e. And so this is x equals e to the y, like this. We very rarely write this as log base e. Instead, we use the abbreviation ln, which is called the natural log. And we say the ln of x equals y, and that's the same thing as saying x equals e to the y. So feeling comfortable going back and forth between the two different forms, logarithmic form and exponential form. There are some properties that you need to be aware of. Actually, you need to know them, not just be aware of them. Okay? 1, the log base b of 1 is always 0. It doesn't matter what the log is. That means that the natural log of 1 is 0. This is going to show up in a lot of equations, and it'll be awfully nice if you could just see a natural log of 1 and then get rid of it, because it's 0. If the base matches the argument, log base b of b, the answer is 1. Therefore, the natural log of e is equal to 1. The log base b of a product can be broken apart into the log base b, log base b into an addition problem. I am not going to explain why this is true. I'm just going to remind you that it is true. We can make the same statement then with natural logs. So if you have the natural log of xy, that's the natural log of x plus the natural log of y. 3 of these properties. We have the division one, the log base b of x divided by y turns into subtraction. Log base b of x minus the log base b of y. And for natural logs, the same thing. The natural log of x divided by y is the natural log of x minus the natural log of y. And the log base b of the base to a power of x to the, I'm going to put n here instead of y on y, x to a power is equal to n times the log base b of x. These are all properties that you worked with last year. The natural log of e to a power, e to the n, is n times the natural log. Let me get that over again. It's not supposed to have an n just yet. The natural log of x to the n is n times the natural log of x. So those are properties that you need to be aware of and be able to pull out of your pocket whenever you need them. You should be able to expand expressions using these properties. So, for example, if you see this, the natural log of 10 over 9, you need to recognize that that's the natural log of 10 minus the natural log of 9. And I know that doesn't seem to help you very much, but when there's x's and y's and things in there, it will help you. The natural log of the square root of 3x plus 2, that's the natural log of the quantity 3x plus 2 to the 1/2 power. So that's a base to a power. So we can put the 1/2 in front of that. 1/2, the natural log of 3x plus 2. You cannot break that up. That's an addition right here. This is addition, and there's no property for breaking that up. The natural log of 6x over 5 squared. Okay? I'm going to do this piece by piece. First, I'm going to pull that exponent down, 2 times the natural log, 6x over 5. And then I'm going to switch to the subtraction, 2 times the natural log of 6 minus the natural log of 5. And then if you wanted to, you could do that distributive property. Whether you have to do that or not sort of depends on where we're going with this. Okay? I think I left something off. Natural log of 6x, sorry. There it is, 6x. And then kind of hiding right here is that that's multiplication. That's 6 times x. So you can further break that up. 2 times the natural log of 6 plus the natural log of x. And again, you can do that distributive property. 2 times the natural log of 6 plus 2 times the natural log of x minus 2 times the natural log of 5. And whether you have that 2 on each of them or pulled out, factored out, it doesn't make any difference. Usually if you do a few of these, you can sort of skip some of the steps along the way. One more expansion. The natural log of x squared plus 3 squared divided by x times the cube root of x squared plus 1. This is just a harsh one, but it's really not that bad if you know what all the properties are. Okay, so the first thing is to break this up. Okay, the natural log of x squared plus 3 squared minus the natural log of x times the cube root of x squared plus 1. Then I'm going to look at each of these individually. With this one, I can pull that 2 out in front. 2 times the natural log of x squared plus 3. And with this one, I've got a couple things going on, but the first one is that multiplication right there. So this is minus the natural log of x plus the natural log. I'm going to go ahead and change that to an exponent. 1/3. Notice that I put brackets, and that's to make sure I don't forget that that minus is attached to everything that comes from this natural log, all of it. And I just have to copy this again. Remember, you can't break them up if it's a plus, okay? So this will be minus the natural log of x, and I'm going to go ahead and distribute that minus, and then I'm going to pull that 1/3 down, 1/3, the natural log of x squared plus 1. All right, so that's expanding, using the properties to expand. And then the second thing is to go in the other direction, and that is to use the properties to combine, or sometimes people say condense. Kind of going backwards. So if you start with something that looks like this, that you can get it back into something that looks like this. That's the idea. It's just going backwards, getting really comfortable with these properties. Okay? So all right, might as well go ahead and write a fairly complicated one here. Okay? Work with each piece, these two pieces first. So this is the natural log of x cubed, and this is the natural log of, I'm going to just go ahead and say the square root of x squared plus 1. Okay? That's to the 1/2 power. And so I've got this in the natural log of a single thing and the natural log of a single thing, and now I'm going to put those two together. This is minus, so it's going to come together as division. Okay? I might as well do one more example of that. So you've got a couple of them in your notebook. I'll do this one. I'm going to start on the inside. I can't, that's already one term and one argument, that's a plus. You can't do anything with that. So I just need to put all these together. Okay, I'm going to leave that 2 for later. 2 times the natural log of, this is going to be, the 8 is going to be in the numerator, minus, so that's going to be in the denominator, also minus, also going to be in the denominator. All right, and then I'm going to deal with this 2 out here, pull that up and make it an exponent. Whole argument squared. Okay. All right. So using the properties to expand or to condense. Next, I need you to remember something. E is just a number. E is approximately 2.7 something out to 3 dozen places, 2.718. You should be able to find this on your calculator. There are 2 places. I have written down here that the 2 places you can find that are second and the division key, and the second place you can find it are second and the LN button. One of those says just E, and one of them says E to the X. If it says E to the X, and you want just E, then you would just say E to the 1, and that would give you that decimal if you ever need it. okay? It's a piece of information that you ought to know. We are going to look at solving some equations. L of x equals 0. You probably should memorize this one, but I tend to rewrite these in exponential form. So the exponential form is the base, e to the power 0 is equal to x, and anything to the 0 power except for 0 is 1. So there's my solution. The primary technique for this is to rewrite it in exponential form. Okay? There's a second one that you probably should memorize. But if you don't memorize it and you remember the process, write down the base, e to the power 1 is equal to that argument x. And so x equals e. These two are going to show up a lot. So if you can get those memorized, life will be better. Ln of x equals 2. If I say solve this, tell me what x equals. E squared equals x. I don't know what e squared is. It's 2.718 something squared. Something smaller than 9. 2.7 squared is something smaller than 9. I can push this into my calculator if I need to get a decimal approximation, but this is considered an exact answer, and it's going to be a perfectly good answer for many things that you're going to do. The ln of x is equal to -1. Again, rewrite it in exponential form. E to the -1 equals x. In other words, x equals 1 over e. That's an exact answer. It's 1 over 2.7. It's in the general vicinity of 1/3. Not exactly 1/3, but it's kind of close to 1/3. Again, you could pop that in the calculator if you needed a decimal approximation for it. All right, so now we'll throw into the mix being able to rearrange a little bit before you solve. I'm going to add 4 to both sides. The natural log of x equals 4. And so e to the 4 equals x. Easy enough. And the last one. All right, and this one, okay, well, we could rewrite this in exponential form, but that doesn't really do us a whole lot of good. That just makes it, I think, almost worse. So I'm not going to go with that option. This one I'm showing you because I want to remind you that sometimes you need to be able to solve by doing them on your calculator. Put ln of x in y1, put x plus 1 in y2, graph them on your calculator so that you see what y1 and y2 looks like. This is what ln of x looks like. X plus 1 looks like this. And you can tell from that graph that there is no point of intersection. Sometimes the answer is no solution. You need to be aware of that. Okay, so hopefully you remember most of that stuff. Okay, let's stop and take a look at what the graph of y equals ln of x looks like. Make sure you understand it and remember it. Okay, I'm not going to remind you of why it looks like this. I'm just going to draw it for you. It has a vertical asymptote at the y-axis. Has a vertical asymptote. So the domain of this function is x is greater than 0. The range is all real numbers. It is an increasing function. Okay. We should be able to lock down a handful of points. This is a really good point to lock down on this graph. That's the point 1, 0. This is a really good point to lock down on the graph. That's the point e, 1. Okay. And this point, the next one, e squared, 2. The next one would be e cubed, 3. These are all points on this graph. This point right here is 1 over e, -1. 1 over e squared, -2, and hopefully you see the pattern for that. Okay, this is a graph that you need to memorize. At least 3 points on it. The two major ones, this one shows up a good bit, and this one shows up sometimes, and you should be able to extend it to some other points if you need to. Just looking at the graph, if I asked you to say, what is the ln of -1, if I asked you to find that, you can see that this is outside the domain, so there is no such creature, okay? And just as a connection to seeing that, that's because I'm asking you, e to what power is equal to -1? E is a positive number. You cannot take a positive number and raise it to a power and come up with a negative number. That can't be possible. You should be able to take that graph and sketch it fairly quickly. Okay, you should be able to take this graph and sketch it fairly quickly. Boom, boom, boom. Get these 3 points on it. 1, 0, e, 1, and 1 over e, -1. Start with those 3 points and then do some transformations on it. Simple transformations. Like, if I said what's y equals the ln of x, put this way, +1. Okay, you would move it up 1. Which doesn't change the domain. If I said f of x equals the ln of, and I said x plus 1, you would move it to the left 1, changing all of the x values. Remembering that e is about 2.7, so that should help you with shifting and how that looks. Okay, probably even different names. G of x. If I said 2 times the ln of x, you would keep the same x values and double all the y values, okay? It doubles all the y values. If I said negative ln of x, that's a reflection about the x-axis. Keep all the x values, flip the whole graph over, and change all the y values to their opposites. So all of those transformations that you did last year over and over and over again, okay? I'm going to turn the page. I want to, well, let me get one more on here. Y equals ln of -x, which is a reflection about the y-axis. So when we have transformations that involve x, it's going to change our domain, and you should be aware moving that vertical asymptote, making sure that vertical asymptote gets transformed when you move things to the left and right, when you do any of those horizontal transformations. And 2 other ones that you should be aware of. Y equals the ln of the absolute value of x. This means that if I ask you to find, let me do this in function notation instead, I like it better. If I ask you to find f of -2, I'm actually going to be able to do it now. I can't do the ln of -2, but the ln of the absolute value of -2 is the same thing as the ln of 2. And so what you get is this mirror image on the left side of the x-axis, of the y-axis. So here's the original, here's the right side. You're going to get a mirror image over here. That's what happens when you put the absolute value on the x. If instead you put the absolute value on the whole thing, like this, then what that does is it takes any part of this graph that's below that part will go away and will flip up here and get reflected to the top. So this point is still 1, 0, and this point over here is still e, 1. But when you flip this up, it was down here, it was the point 1 over e, -1. So it's going to end up being 1 over e, 1. Oh, I didn't line that up very well. Those two should be lined up. Okay, so simple, basic transformations. Okay, you've got several problems. The first batch of problems on tomorrow night's homework, on Friday night's homework, are on page 329, I believe. And those are the problems that go along with these LN pieces of information. Just one more time, keep in mind, try to get this memorized. The ln of 1 is 0. The ln of e is 1. And this other thing, the ln of e to the n, if you have the ln of e to the n, that answer is n. If I say the ln of e squared, the answer is 2. If I say the ln of e to the 4th, the answer is 4. Those, that's going to help us when we get around to solving equations. Okay? That information also has got a few examples in your textbook in section 5.1. All right, the next thing is a review of exponential functions. And this is in your textbook in section 5.4, but the sooner you remember this information, the better off you're going to be. All right? We're going to start by looking at the function f of x equals e to the x. And I'm reminding you of what that graph looks like. And that graph looks like this. This point is 1, 0. This point, sorry, this point, got that backwards, sorry, is 0, 1. This point is 1, e. This point is negative 1 over e. And I'll just remind you right now that this graph is the inverse of the Ln graph. If you go look at your points, they are just flipped over. The x and the y's are just switched. And so sometimes kids can remember this better. Well, I personally remember this graph better, and then I can get the Ln graph if I've kind of forgotten what it looks like, okay? The domain of this is all real numbers, and the range of it is 0 to infinity, okay, or y is greater than 0. There is a horizontal asymptote, the x-axis, horizontal asymptote that you need to keep up with. It is an increasing graph. All of these are things that you talked about last year. Okay. You should be able to do some simple transformations. If I ask you to do e to the x, I put plus 1 here, that's up 1. Leave the x is the same, move all the y's up. If I ask you to do e and I raise the power to the x plus 1, that is a left shift. Move it to the left 1 and keep the y values the same. If I ask you to do negative e to the x, I need to kind of make sure that you know the difference between negative e to the x and e to the negative x. Those are two different transformations. The top one is a reflection about the x-axis. It changes the y values. The bottom is a reflection about the y-axis. It changes all of the x values. So basic transformations, okay? Spent tons of time on that last year. Okay. C and A are positive real numbers. I give you this function that has this characteristic. So C is some positive real number and A is some positive real number. Then what we get is the same basic shape of e to the x, okay? But we have that C gets popped in here in a couple of places, all right? And specifically, it's right here. This will be 0, C. And up here, this will be 1, whatever C is times E. And then this point over here will be negative 1, whatever C is divided by E. And it would be a good thing also for you to memorize this basic shape as well. This is an exponential, something called an exponential growth model. If you put a negative value here, right there, then that graph is going to turn into a decreasing graph, okay? And it's another transformation that you ought to be able to pick up. And this value right here, once again, will be C, okay? Those are going to be important in some of the application problems that we do. All right, now some solving. Just a couple of equations, a couple of pieces of information. This is not really solving. If you say e to the ln of x, that answer is x. So if I say e to the ln of 2, that answer is 2. If I say the ln of e to the x, that answer is also x. If I say the ln of e cubed, that answer is 3. Being able to do that is going to make life easier for you. Okay, being able to recognize that. You just do one more of these. If I say the ln of e to the x plus 1, then what's that going to be? X plus 1. Okay? Exponential functions follow all the properties of anything that's got exponents. So I think it just feels a little bit funny when we do them. If we have e to the a times e to the b, that's e to the a plus b. If I have e to the a divided by e to the b, that's e to the a minus b. And if I have e raised to 1 power and raised to a 2nd power, then I'm going to multiply those powers. Okay? The same rules as if that base were x. Exactly the same rules. And then just another reminder, e to the 1 is just plain old e, and e to the 0 is 1, and e to the negative 1 is 1 over e. Just things that are going to make your life easier if you keep all of this in mind. Almost there. Now we're going to solve. Okay? The typical way of solving is to undo what's there. This is an exponential form. I'm going to just simply change it into log form. Sometimes this is taught by taking the log of both sides. I'll write it that way once, but I don't ever bother doing it. Taking the natural log of both sides, like this. And here's this thing that I just showed you. The natural log of e to the x plus 1 is x plus 1. And I hardly ever write that step down. I just look at it as changing it to the log form. Log base e of this is the exponent. All right, and then we can solve it from there. It always throws people off to recognize that this is an answer. I have no idea what the natural log of 7 is. If I needed to know, I would look it up in a table or I would get it off my calculator. Okay. I put those parentheses there for clarity. I don't want to confuse this with the answer of the natural log of 7 minus 1 and have anybody think it's that answer. So I just put those parentheses for clarity. Let's put another one. Okay, going back and forth between logarithmic and exponential form, I'm going to turn this into log form. And again, it's often taught that you take e and raise it to this power. I'm telling you, I'm going to write it down here, but I never do this on paper. I always skip this step, because when you get e raised to the natural log of stuff, the answer is the stuff. And it's just as easy to think of that as rewriting this as in its exponential form. E to the 5 equals the argument of the function. All right, e to the 5 is just some number, so you're going to add 3, and you're going to divide by 2. I have no idea what that number is. If I really needed to have a sense of it, I would drop it into my calculator and come up with a solution. Okay? All right? I need to get back to the x, so I need to get rid of all of the stuff that's wrapped around it, starting from the outside. Add 2 to both sides. Divide both sides by 4. You can put 0.75 if you like, although I usually leave it in fraction form. Now the next thing, I got to get this out of the exponent. That means I need to un-e it, or put it in log form. The natural log of 3/4 is negative 2x. Okay? I'm now going to divide both sides by 2. The natural log of 3/4 divided by 2, or you can say 1/2. In fact, I kind of like that better. I'm going to say times negative 1/2 in front of it is equal to x. And there's an answer. Now, the AP Calculus people might mess with you a little bit when you're viewing a problem, and this answer might be written in a couple of different ways. Like you might take this and put it as an exponent, the natural log of 3/4 to the negative 1/2. Or you might change that, the natural log of 4/3 to the positive 1/2. Or you might notice that you know what the square root of 4 is. What's the square root of 4? It's 2. And then just have the 3 to the 1/2. Sometimes they do that when they're messing with you on the answers to the multiple choice questions. Okay? One more. Last one. Okay? So I'm going to get back to the x. I'm going to subtract 2 from both sides. 3 minus 2. I'm going to divide both sides by 5. 1/5. I'm going to put it in log form. The natural log of 1/5 equals x minus 1. Sorry, I made a mistake on my paper. And then I'm going to add 1 to both sides. So the natural log of 1/5, set in parentheses for clarity, plus 1. And there's my answer. This is a beautiful answer. There's nothing wrong with this answer for exact. You can type it in your calculator for a decimal approximation. But there's one thing here that is a little hidden, and it's so easy to miss. And that's knowing this. The natural log of 1 is one of those things that I told you I wanted you to get memorized. Make sure that you know what the answer is. When I say what's the natural log of 1, you need to know that that answer is 0. And then you kind of need to see it here. This is the natural log of 1 minus the natural log of 5. This becomes 0 minus the natural log of 5. So I'm going to just write this in a different order instead of plus 1. 1 minus the natural log of 5 is equal to x. This is considered a simpler answer than this answer up here, which is a lovely answer. They're both right. Okay? All right, these problems, there's a little bit more explanation or a few more examples in section 5.4 of your textbook, and these problems are on page 356 of your book. I need you to have reviewed all of those problems, worked as many as you can, and checked the online answer key before you come to class next week on Wednesday. That's it.